Welcome to The Explainer. Today, we're talking about a brand new AI system that could totally change the game for scientific discovery by automating one of the single biggest hurdles that scientists face. All right, so let's just jump right in. What do you think is the biggest thing slowing down modern science? I mean, is it a lack of great ideas? Are we just short on data? Well, it turns out, a lot of the time, it's not about the ideas at all. The real bottleneck is the incredibly slow, tedious work of just writing the software you need to test those ideas. Think about it. Say you're a scientist with a brilliant idea for a new way to detect deforestation using satellite images. That's great. But now you have to actually build it. Writing the code, testing it, debugging it, that can take months, sometimes even years. The idea is often the easy part. And there's actually a name for this kind of software. It's called empirical software. Basically, it's any program where the whole point is to get the best possible score on some specific goal, like making a model as accurate as possible. And this isn't some tiny, obscure corner of science. We're talking about the software that powers everything, from the weather forecast you see on the news to Nobel Prize-winning research. Okay, so we've got this huge bottleneck, right? So what's the solution? Well, the research we're looking at today introduces an AI system built to do exactly that. It's designed to automate the whole process. You can almost think of it as an AI assistant for the scientist. So how does it work? Well, it's a really smart combination of two different AI components working together. First, you've got a large language model, or LLM, which acts like the creative writer. Its job is to generate and rewrite code. But, and this is key, it's not just spitting out code randomly. It has a partner, a tree search algorithm. Think of this part as the strategic coach. The coach is constantly looking at the code the writer produces, scoring it, and telling the writer which ideas are good and which ones to scrap. It's a real team effort. So this writer and coach, they're locked in this constant feedback loop. It's a cycle. You give the AI a task, the LLM writes a solution, the system tests it and gives it a score, and then it learns and tries again. The coach tells the writer, okay, that was a 6 out of 10, try changing this part, and it just keeps going over and over. It's like a chef endlessly refining a recipe, but it's happening at a speed no human could ever dream of. Yeah, and this quote from the researchers really nails it. The magic here isn't that the AI is smarter than a person. Its superpower is that it is absolutely tireless. It can search through a mind-bogglingly huge number of possible solutions without ever getting bored or giving up. And by doing that, it can find those one-in-a-million, needle-in-a-haystack ideas that really push science forward. Okay, so that all sounds amazing in theory, but here's the billion-dollar question. Does it actually work? Can this thing really go head-to-head with human experts and win? Well, the researchers put it to the test in a whole bunch of different scientific fields, so let's dig into the results. First up, genomics. They gave the AI a really tough problem, analyzing single-cell data. And the result was just, wow. The system discovered 40 brand new methods that were better than every single method designed by humans on a public leaderboard. I mean, think about that. Not one, but 40. That's incredible. And the really cool part is how it did it. This wasn't just the AI tweaking a few numbers, it was actually innovating. So the best human-made method was a technique called BBKN. What the AI figured out was that if you take a totally different method, called combat, and run it before you run BBKN, the results get way, way better. It literally discovered a new recipe by combining two ingredients no one had thought to put together before. So what about another field? Epidemiology. This time, the challenge was to forecast COVID-19 hospitalizations, competing against the best of the best. The AI came up with 14 different models that were more accurate than the CDC's own official forecast. And that CDC forecast, that's pretty much the gold standard. The AI beat it. And the winning streak continues. Let's look at geospatial analysis, basically teaching a computer to identify things in satellite photos. The previous best-in-class method had a performance score of 0.762. The AI solution, it blew past it, hitting a score of 0.82. Now, that might not sound like a huge difference, but in this field, that is a massive leap forward. And it just keeps going. This wasn't a one-trick pony. In neuroscience, it was better at predicting brain activity in a zebrafish, general forecasting, top of the charts, even pure mathematics. It created a better way to solve really difficult integrals that trip up standard software. You see the pattern here, right? This is a general-purpose discovery engine. Okay, let's step back for a second. These results are obviously super impressive, but what's the bigger picture here? What does all of this really mean for the future of science? The bottom line is speed, an incredible, revolutionary acceleration of the entire scientific process. I mean, science is all about trial and error. This system takes that whole cycle, the part that can take months or years of a scientist's life, and it crushes it down into a matter of hours or days. That is a total game changer. And that really leaves us with a huge and kind of exciting question to think about. If you give scientists a tool that automates the most boring, tedious part of their job, what happens next? What new frontiers can they start to explore when they're not bogged down writing code all day? What crazy, ambitious questions can we finally start to answer when our imagination is the only thing holding us back?